So it's a pleasure for me to introduce Fernanda today. Fernanda is a medical doctor from UNAM, University National of Mexico. And she also got a PhD in neuroscience here in McGill from the Integrative program in neuroscience. Fernanda is also the director of communications of Convergence Perception of Neuroscience. And this particular talk, which is about creativity and the brain, is inside of our series of talks on science and art, and how the mix of both disciplines can bring new ways to see science and see art and bring this to the public. So we really are really happy to have Fernanda today here, who will talk about the crossover between these two disciplines and how she has done an amazing work in communicate science to other people, not just people here in Montreal working with Convergence, but also in Mexico with a particular fantastic project that she had popularizing science through videos and YouTube. So I'm really happy to have Fernanda here, and no more presentation. Fernanda, the floor is yours.
Thank you. So thank you everybody for coming. It's always good to talk to friends, see like some known faces. So I'm going to speak today about a project that is also in the intersection of art and science, a little bit on the side of broadcasting neuroscience and broadcasting neuroscience of art. So sharing with the public what's being done to know what are the underpinnings, the neural underpinnings, or the works happening on the brain when we perceive or when we create art. So first of all, I'm just going to briefly speak about science communication and why science communication. So when I was doing my PhD in neuroscience, I often found myself isolated, and I found a lack of communication within science, and that made I felt that science was sometimes trapped inside people's labs. So you were working on a very particular project that only other 10 people in the world understood, and that makes sometimes feel the work of a scientist kind of futile. So just to say that for me, science communication was a little bit of a way to survive grad school, and a way to develop other skills that would help me not only do science in the lab, but also share science and share my passion for science. So when I speak about my way in science communication, I always refer to an anecdote. So this is an anecdote that happened to me during the Cognitive Neuroscience Society meeting in 2016. So just before I speak about this, I'm just going to briefly introduce a concept, which is the concept of the human connectome. So for those that do not know what the connectome is the, let's say, the mapping of all the connections of the neurons in the human brain. It takes the term from the genome that was mapping all the genes in the human biology, and attempts to do this with neural connections. So the human connectome would be, mapping the complete human connectome would be finding all the connections between neurons in the brain and how information is transferred between one to another through these connections, right? So I was in this Cognitive Neuroscience Society meeting in 2016, and there was a great debate on connectomics. So I was there and I was hearing the debate, and at the end of the debate, questions were asked. So I asked one of them who was debating, saying against the connectome, I asked okay, so if you think that this is not as useful and as impressive as it seems to some people, this was one of the concepts that impressed me more before I started my degree in neuroscience, so I thought this is fascinating, everybody should know about it, right? But there was one of the researchers in the debate that was saying that too much attention was focusing on this, and this was not as important. So I approached him and asked him, so what would you tell people to look for, if not the connectome? What else in neuroscience can contribute to our knowledge? And his first answer was to say well, it depends if you want to get funding, or very science stuff, right? So I asked him no, because I was writing back then an article on the connectome for the McGill Daily, which is the McGill independent journal, and I wanted to do something more for the general public. So I asked him okay, but if you were to tell a member of the general public why the connectome is not as relevant as everybody says, and what else to look for in neuroscience, what would you say? And so he basically asked me that, he had basically answered that he thought that the mythical member of the general public didn't give a crap about any of that. And everybody laughed, and I felt ashamed, and that was the end of the anecdote. So this was very meaningful and relevant to me, because that was like one of the proofs of how some scientists work in their daily lives. So they think that science is for them and for their labs and for other fellow scientists, and the only point of communicating scientists is communicating to the government that's going to fund your science, and the rest doesn't matter. So there's no general public. This guy, it's a mythical figure, and he gives a crap about whatever we do in the lab. So in the meantime, while this guy and other scientists in their small spheres think that the member of the general public doesn't exist and is a mythical creature, there are some other people from the general public that think of scientists and science spheres as mythical creatures as well, and that have access and will to communicate to broader audiences. So while some scientists are keeping the science for themselves and saying, oh, I'm not having interest in sharing any of this, this is happening, right? So anti-vaxxers have powerful campaigns in social media to share their message, saying that vaccines are dangerous or can cause autism, which is generating outbreaks of measles and stuff that we hadn't seen in a long time. And some people are discussing again if the earth is flat or round. And because these people were so famous on YouTube and were having so many followers, and people were starting to believe again that the earth is flat, now it's becoming a conversation again. In 2019, there's articles on important journals saying, yeah, remember the earth is round and this is why. So this is one of the examples on how reaching an audience is important. And some of the things that people that deny facts do is that they know how to reach audiences. So while we scientists think that we're doing very important things in our labs that nobody has ever seen, these people are broadcasting 24/7 their theories and their propaganda. So while I was doing my PhD, as I said, I started doing some work to move science out of the lab. I published some articles in journals such as the McGill Daily about different topics in science and neuroscience, and also in some journals and newspapers in Mexico. And then the next experiment was trying to move science from the lab to social media. These are some graphs that you don't need to really see, because I guess every one of you uses social media and internet a lot. So even if I didn't have these graphs, you would believe me if I say that people use a lot of time online. And from the time that they use online, they spend a lot of time on social media. And this is on the rise. This is only 2016, but if you go to the actual graph, you'll see how it's keep going up. So it was, I think, less than 2 hours in 2012, and now we're in an hour, 2 hours and a half per day used on social media. So there was an image missing here, but so I once ran a first experiment that was opening a Facebook page of science dissemination called Juga Cerebralia, or Juga Cerebralia in Spanish, that was meant to just share neuroscience content in the simplest way possible and get people interested. And I kind of studied how that worked. I had kind of 1,000 or a little bit more 1,000 followers. I would see what things people would share more and less. And it was like a first platform from which I explored how to bring science to social media. And then something that I really like and that I'm really into are videos that broadcast science in lay terms or use animations or simple drawings or easy graphs to share complex concepts or ideas. So there's a lot of educational videos about neuroscience and other stuff in science in English. These are three that I particularly like. You know, you're probably familiar with TED Education. They have animations and videos between 2 and 8 minutes explaining different concepts. So this particular one is what percentage of your brain do you use? And this is ASAP science. So they use drawings kind of made in whiteboards as animations to explain some stuff about the brain and different stuff. And this is one of my favorites. I don't know if you know her, but she's pretty cool. But we don't have sound. So this is Shannon Odell. She's a PhD in neuroscience.
Hi, my name's Shannon, and I'm a neuroscience PhD candidate. I'm here to explain to you exactly what happens to your brain as you drink. Here we go. Once swallowed, this drink travels to your stomach, where about 10% of the alcohol is absorbed, and then on to your small intestines, where the rest is absorbed into your bloodstream. As our liver can only metabolize about 15 milligrams per deciliter per hour, 1 drink per hour is all your body can effectively metabolize. Anything above this leads to alcohol accumulation in the bloodstream, leading to intoxication symptoms. Alcohol is metabolized in your liver by 2 main enzymes, alcohol dehydrogenase and aldehyde dehydrogenase. First, alcohol is metabolized by alcohol dehydrogenase into acetaldehyde, which is a toxic compound. Buildup of this stuff is thought to be the reason for your nasty hangover symptoms. Acetaldehyde is then metabolized by aldehyde dehydrogenase into acetic acid, also known as vinegar. When I drink, I like to think of myself as a cute little vinegar factory. After 2 drinks, the signs of intoxication may begin to surface. You may think it's a good idea to send that text or to insert yourself between a conversation between 2 strangers. But why does alcohol do this? GABA neurons are inhibitory neurons, or the stop neurons on your brain. By activating GABA receptors, alcohol works to increase firing of these stop neurons, therefore decreasing overall activity in certain areas of the brain. It doesn't stop there though. Alcohol has the ability to squirm its way into glutamate receptors. Glutamatergic neurons are excitatory neurons, or your go neurons. So alcohol finds another way by inhibiting these glutamatergic neurons to decrease overall brain activity in certain areas. One of these areas is the prefrontal cortex. I like to think of it as the mom of your brain. So as you drink, activity of the prefrontal cortex goes down, making you less like your mom and more like your crazy aunt. But I know what you're saying. But alcohol makes me feel good. And there's a science behind that. Alcohol causes increased firing of dopamine-releasing neurons. Now, dopamine is your feel-good neurotransmitter. Dopamine also causes the reinforcing effects of alcohol, thus causing you to grab for that next drink. Bottoms up. At about 3 to 5 drinks, or a blood alcohol concentration of 50 milligrams per deciliter, additional side effects of intoxication may begin to surface. This may include incoordination or lack of balance. Now, this is due to alcohol's effects on the cerebellum. The cerebellum is in charge of coordination. It interacts with your peripheral nerves in your arms and leg to coordinate coordination. It's important to note that chronic use of alcohol can result in chronic impaired nerve damage, which can include permanent damage to nerve tissue, and causing permanent imbalance. Oh, that's bad. At 10 drinks, the signs of alcohol intoxication start to get rough and include vomiting, nausea, anterograde amnesia, blackouts, and marked slurring of speech. Now, after 10 drinks, things get even worse, and side effects include hypothermia, hypoventilation, cardiac arrhythmia. Now, I'm no idiot, so I'm not going to do that. But never forget, alcohol is poison. You get that one?
I don't know if you already knew her, but I think you should always acknowledge your inspirations, and this woman was, and her videos were definitely a big inspiration to decide to move on from writing science to doing videos, broadcasting science. Of course, she's an actress, so she's way funnier than I am. I'm not really funny. Except when I say that I'm not funny. So that's like, I'm doing a different kind of thing. But I think that, I mean, you see that and it goes round. She has like, this is your brain on breakups, this is your brain on puppies or kittens and stuff. And I think it works well. It's, it flows, it's interesting, it's funny, and people can approach that and actually get some knowledge and concepts that otherwise they wouldn't have like known in their everyday lives. If they're not in the biology field or in the neuroscience field, like I think this is a very good and useful way to broadcast science. So, leaving a little bit of the science communication part, we already spoke about SciComm, and now I want to speak a little bit about ArtSci or SciArt. Like, as you know, Convergence Perceptions of Neuroscience, so this organization that organizes these Art-Sci talks and some exhibitions, and I'm going to talk more about that in the end, wants to engage in transdisciplinary practices and engage dialogue between artists and scientists and people that are in other spheres, right? And that's something I'm really interested in as well. That was one of my reasons for joining Convergence, because I feel that we should move towards transdisciplinarity. One of the downsides of science, as I said, is everybody's isolated in their own field. And if you want to read something from another field, it's going to be very hard for you to go in. And this allows, this restricts the transfer and the exchange of knowledge among disciplines and among researchers and professors. So this is Eric Kandel. He won the Nobel Prize. The presentation's in Spanglish because I presented it in Spanish and then translated it. I forgot some parts. This is Eric Kandel. He won the Nobel Prize in Medicine and Physiology in 2000 because he described the molecular mechanisms when you form a new memory. So studying in a snail, in a sea snail actually, he studied how the neurons wired when the snail learned some behaviors. And he won the Nobel Prize for that. But besides that, he's becoming an advocate of science-art exchange and a broadcaster for this. He's wrote a couple of books on the intersection of art and science. One of the things he says when he speaks about science broadcasting is the following. He cites a very famous essay by C.P. Snow, who spoke about the two cultures, speaking about science and culture or humanities as two cultures that were sometimes hard to bridge. So he wrote this very famous essay that people that are interested in ArtSci keep citing today. So this is Eric Kandel's words. Eric Kandel citing C.P. Snow. Me citing Eric Kandel citing C.P. Snow. So he says, C.P. Snow spoke about the divide between the humanists and the scientists. Everybody can read Shakespeare, so the scientist can be literate in some degree. But the humanists do not have access to science, and we need to change that. One way to do this is to find areas of common interest and to start a dialogue between us. And this is a fantastic time to do this. So I find that what he says is really accurate. Like, you can be more or less literate. But if you go to a museum and like stand in front of a work of art, it will tell you something. You have access to it. How deeply you understand it or how you interpret it, that's another thing. But if you want to have access to science in its pure form, I just go and look for a journal and open like a scientific article, an experimental article, and I guarantee you that it's going to be very hard to understand. Like, if it's outside your field, it's going to be full of jargon, complicated statistics, and it's going to be very, very hard to digest. So let's say you're an artist or you're a humanist and you're interested in neuroscience of creativity, or you're interested in neuroscience of, I don't know, visual art, and you want to go and look at the papers. You go and try to take a look, and what you find is that you have no access. So the way to change it is to start a dialogue, and so he says that we can engage dialogues and we can broadcast science to engage transdisciplinary dialogues and look for areas of common interest. So which area could be more attractive and powerful than art? We've all been exposed to art. We all like art in its different forms. So I guess I find that it's a great topic to start an exchange between humanities and science. For that, you need to broadcast the science. You need to bring the science to terms that people that are not in the field will understand. So, we come back to the question, right? So why art and the brain? So there's a lot of reasons. One of them is that neuroscience can help us understand our way to perceive and create art, right? Because it's all happening inside our heads. On the other side, art can help us also understand our brain functioning. And we're going to go a little bit and speak in detail about that. Another one is that art can have a therapeutic properties for neuropsychiatric conditions, and we're seeing that more and more, like using music therapy or dance therapy to treat Parkinson's disease, Alzheimer's disease, like not necessarily to treat, but improve the people's functioning in this condition. So also, art can be a powerful vehicle to broadcast neuroscience. Art engages the public, and science in its pure form sometimes doesn't engage the public. So you can combine both, and that's a little bit what Convergence does. to like generate this dialogue. And then also, the knowledge of neuroscience can inspire new works of art. And then, obviously, all of the above. So, I'm going to talk more about the first and the second one, exploring art through neuroscience and exploring the functioning of our brain through art, because that's what my broadcasting project is about. So there's two branches that are relevant for this enterprise. One of them is cognitive neuroscience. So cognitive neuroscience is it's a branch of neuroscience that happened with something called cognitive psychology that used to study like mental processes, and the biology of the nervous system merged. How did they merge? One of the things that helped was what we call functional neuroimaging. So this is the techniques that we use to be able to measure brain functioning in real time, what people are doing, different tasks. So you can sit somebody down in a functional MRI scanner or put like an EEG cap on somebody and make him or her do a task, and then analyze the activity and draw some conclusions of what's going on while he's engaging in A or B or C. And this allows us to explore biological underpinnings of creativity, memory, empathy, perception, emotion, and all of these are processes that are relevant for our art perception and also for art creation. And the second one is neuroaesthetics. So neuroaesthetics has been there for a while, but it's an interesting example of a transdisciplinary field. And it aims to study the biological basis of the aesthetic experience. What happened when we experience a work of art? Before functional neuroimaging, it used to be done with, for example, patients that suffered lesions and something changed after the brain damage in the way they perceived art or created art. So these are examples of people that do either broadcasting or research in neuroaesthetics or cognitive neuroscience. Two of them are based in Montreal, actually, because we have a big center here at the Brahms and researching music and the brain. So there's Fernanda Pérez, who's the director of the Brahms, and Robert Satorre, who's a neuroscience of music researcher. We also have Margaret Livingston there. She's a neuroscientist of vision, but she has done a lot on art and vision. And we have Samir Seiki, also a neurophysiologist of vision that is interested in the brain and art. And also Ramachandran and Eric Kandel, who are two brother neuroscientists, but that are interested in broadcasting art and the brain. So all of this brings us to my broadcasting project, whose name is Synapsis, Conexiones entre el arte y tu cerebro. This is done for Spanish-speaking public. So it's a broadcasting project about art and the brain in the forms of like videos, YouTube videos, such as the ones we showed, kind of. And it aims to build like 6 capsules around the following topics. So creativity and the brain, art and visual perception, literature and the brain, the musical brain, dance, and cinema. So basically the different arts, except for maybe theater and all the visual arts. And the whole, it's been financed. I got a grant from the Mexican government for the Ministry of Culture from a program that's Art, Science, and Technology. So through the content of this project, we can do we aim to do the following: to share some basic concepts about the brain, kind of what Sharon O'Dell was doing, like while explaining drinking and the brain. She spoke about GABA, about inhibitory neurons, excitatory neurons, but through different stories, through different narrative, more than a class of like these are the concepts, right? So it also aims to debunk some myths. It interviews some experts on different topics. So we bring in an expert in musical cognition, and he gives us a 2 or 3 minutes explanation on his work on the lab, and one for each capsule, and also sharing recent research with the general public in lay terms, and afterwards obviously sharing all the references so that they can go, people that are interested can go and see each one of the studies we talk about in the videos. So this is me in the first video. And so far we've recorded 2, the first 2, so creativity and the brain, and visual perception and art, the second still being edited. They have some graphic motion animations to illustrate the concepts. And yeah, so I'm going to speak a little bit more about art and the brain, what we're aiming to share, why this is so rich. So I'm giving some examples. The first one are based on my first 2 videos, capsules. And the rest, because I haven't done the capsules yet, we'll just speak about more broadly what music, dance, and cinema can tell us about the brain, right? So the first one is about what is the biological basis of creativity. Can we look for a neural base for this phenomenon that has defined humankind, the power to transform what's around us and create new things? So who has heard the myth, well, the myth, I'm already saying it's a myth, but who has heard that creativity is on the right side of the brain? You've probably seen like all the images, like, yeah, raise your hands, thank you. You've probably heard you've seen all the images in social media showing always that the left side of the brain is like black and white, chessboard, or very straight lines and squares, and on the right side there's an explosion of color and blah, blah, blah. So this actually comes from some evidence from the beginning of the research in neuroscience of creativity and the neuroscience of the connection between the left brain and the right brain, but it's actually been oversimplified and perpetuated through the years. So in this first video, we address this myth. We speak a little bit about what's behind it. So some neurologists actually saw that patients that had damage to their left hemisphere became in some ways more creative or developed some artistic talents. So there were examples, for example, of patients that had a condition, an illness in their left hemisphere, and as the damage progressed, they started showing musical talent or drawing. And some others that show that some kids that had a language problem with the left brain also started showing like some outbursts of creativity. So based on this, what we call lesion studies, which was what the neurologists did before functional neuroimaging, that's where we got our knowledge of what the brain does. So if this part is damaged and we lose a function or we gain a function, it means that this part is somehow involved with this function, right? But what we know today is that it's way more complicated than that. Actually, with studies of neuroimaging have seen that many areas that are involved in creativity, both in the right and in the left side. And that's a little bit what I speak about in the first video. And so we also speak about a concept called neural networks. So somebody doesn't know what neural networks are? Raise your hand. Okay. So before we used to think in neuroscience that there were areas in the brain that had functions, right? So we had the language area, that was the first area that was discovered to have a function in the brain, and then we have this area and this other area. And this was because of the way we saw things, that were the lesion studies, right? But now we know, like modern neuroscience considers that the functions are not like depending on one particular area of the brain, but on many areas, interconnected. Remember when we spoke about the connectome? So there are neurons connecting to each other, and we have networks. So 1 to 3 areas connected together and performing a function. So most of the research in modern neuroscience, what it does is that it looks to how neural networks coordinate each other to engage in creative functions. So in this first capsule, we give some concepts about the basic structure of the brain, what's what, to like help people get into the topic. Then we debunk the myth of the right hemisphere. And we speak about this study, there was a study that was published last year in the Proceeding of the National Academy of Sciences, that found that the connection between different networks was related to how creative was the output of the subjects in a task. So they would bring the subjects to the lab and give them a divergent thinking task. What they do basically is they give them, they show them an object, and they have to say many different uses they could give for that object, or everything that comes to mind, or a place, and they have to describe what's going on there. And then they measure how creative their answers are according to some criteria they have, so how original, and then they correlated both, and they saw that people that had certain connections were more creative than others. So it's a little bit the structure of this first capsule. So I wanted to show you this, but it's in Spanish, so I don't know if I can like somehow turn off the sound so that I can say in English whatever I'm saying in Spanish.
¿Alguna vez has escuchado decir que el hemisferio izquierdo es lógico, racional y analítico, y el hemisferio derecho es holístico, artístico y creativo? Este en realidad es uno de los mitos más difundidos acerca del cerebro. ¿Alguna vez has escuchado?
And so we're staying by saying that this is actually a myth, really artistic, holistic. There's some of it to it, but we cannot explain creativity by saying that it's on the right side.
¿Alguna vez has escuchado?
No. Okay, so this is another example of what we do. This is about solving problems, and it's how some people study creativity. I wonder if there's a way to play it without...
Hay dos
Fernanda, I think if you go in the panel here.
Maybe if I just...
formas de resolver.
My computer.
resolver un acertijo.
Yeah, okay. So, again. So this is basically a part that speaks about how neuroscience and creativity has also been studied with another kind of approach, which is bringing people to solve problems in the lab, like puzzles or stuff, and seeing what happens in their brain as they find the answer. So this basically says that there are two ways to solve a problem or a puzzle. The first is to try once and again different different solutions, and the second is to have a sudden burst of creative insight, the famous eureka. And it explains that how two scientists brought subjects in the lab and gave them a series of problems to solve while they were recording their brain activity. And they basically found that the area of the right part of the brain, on the temporal lobe, showed bursts of electrical activity called gamma waves whenever they found, in 2 moments, with the beginning of the task and with the sudden revelation of the answer. So that's like another example of what we show in the capsule. And this finally is what we were talking about, brain networks, neural networks and creativity. So basically they found that there are 3 neural networks important for creativity. The first one is called the executive network, the second is the default mode network, and the third is the saliency network. So these are parts of the brain that are connected in an organized way. The first one, the executive central network, is the one we use when we focus our attention in one task for a long period of time. So we have to sit down and solve a problem or write an essay or whatever. We have to engage the central executive network to be able to do it without drifting. The second one, which is called the default mode network, is a very interesting one when it comes to creativity. And this is the one that is active when we don't have any task, when we're just daydreaming or sitting down and thinking on our stuff. Then there's activity of our default mode network. And the third one is called saliency network. And this is very related to emotions and to the limbic system, which is the one that controls emotion. And that helps us to detect novelty or relevance in everyday stimuli and also in our ideas in our head. And the way this works basically is that what I'm saying here is you're going to do a task, you sit down, your executive central network is active. Afterwards, it's not often in that moment where you find the answer. So you can sit down for 3 hours and you won't find a creative way to finish your essay or to do your drawing or whatever you're doing. So this network helps you to do things, but it doesn't really help you to find new solutions. So it often happens that when you're taking a shower or when you're going for a walk, then you often have like the eureka moment. So it's in these moments of distraction when you're letting your default mode network get into the action and your ideas to associate in a more free way, then you get these eureka moments. And that's because, and then what these scientists found in this late research that I was showing before was that there's this third network I spoke about called the saliency network. Basically detects the novelty in your thoughts that you're incubating while you're in your distraction, and it kind of switches in between the two networks. The networks that helps you concentrate and do stuff, and the network while you're daydreaming. And it's kind of this switch that can help you find the new idea, the important thing, and get back to work and put it onto the task. So that's kind of like the newest stuff on how it's the biological basis of creativity. So. So that's for creativity and the brain. And then we have other examples of how art and the brain are relevant. So for example, the second capsule is going to be about what art can tell us about visual perception. So here you can go into many concepts. You can explain a little bit of the visual pathway from the eye to the cortex based on different works of art, and explain to people why you perceive some things and on how the brain separates whatever you see. When you see a painting, your brain has to first fragment it and separate it. You see color, there's one area that processes color, one area that processes motion, one area that processes the lines, and then you put it back all together. It also aims to explain how what we perceive, it's actually not a mere reflection of reality. It's something that's constructed by your brain. So your brain deconstructs reality first, separates everything, and then puts it together again in integrated perception. So it gives some examples. So for example, this is the Mona Lisa, and what this painting can show is how our retina, that's a part of the eye that has the first layer of neurons that transmit information to the brain, it has an area, the central vision has a very high acuity. So you can see things in a high precision mode. and the things that are more in the periphery are more blurred. So what, this is from Margaret Livingstone's book, Vision and Art. So what she's explaining is that if you're close to the painting and your central vision is focused on the mouth, you're going to see it very, like in a very sharp way, and you will see that there's no smile. It's just a straight line on her mouth. But when you move your gaze to the sides of the painting, then your peripheral vision that's more blurry, it's activated, that blurs the edges of her mouth, and it kind of seems that she's smiling. And when you get close, she doesn't smile, and when you get far, she smiles again, and when you move to one side to the other. So she's using this famous enigmatic question of the Mona Lisa smile to explain central and peripheral vision. And then you can use other stuff. So for example, pointillism and the different, using points in a picture can induce depth perception because of how we integrate the vision of the two eyes. Yeah. This is one I like too. So why are portraits so powerful? So our brain actually has an area that works for processing faces. So we need to process faces for our everyday social interaction. So our brain is already wired since we're born with an area to process faces. This is called the fusiform face area. It's in a temporal lobe, and that's the part that integrates the face. But there's also another part of the brain that processes every feature of the face separately. So the eyes, the nose, and the mouth. So if you see eyes and mouths without the face, there's one area that will activate, and there's another one that integrates everything. And for your brain to integrate it correctly, it only has to be like in the good configuration, 2 eyes and nose and mouth. And then artists can play with this, making it more cartoonish or less cartoonish or bigger or smaller, but as long as they're in the configuration, we're going to recognize the face from their traces, and we're going to have activity in this area part of the brain. Some other examples of how our brain processes color, for example, if you see this circle here, there's in the inside there's white, but we see more yellow than the outside because we kind of our brain fills white spaces with the color that's closest to it. And this is stuff that painters had already explored widely before. So we go, for example, to music. That's one of the most studied aspects of art and science. We have a lot of studies on musical cognition and also on why music causes pleasure. So some of the interesting studies is, for example, to see that music activates the same reward systems that drugs or food or sex or satisfying basic instincts. So it works on the same circuit that depends on dopamine. So it shows how powerful this thing that apparently wouldn't be important for our survival is, that it activates the same circuits of the brain that some of the most important aspects to the human survival. Music is also interesting because of plasticity. It shows, studies in music and dance show how brains of the musicians and brains of the dancers are obviously wired differently and have different density of neurons in certain areas because of what they learn to do. They learn to, for example, integrate very quickly the input, so the sound, and the output, what they do with their hands. They have to create loops called sensory motor loops. And you can see a non-musician and a musician inside a scanner listening to music, and you will see different areas. So this shows how two people, two humans can transform their brains through learning a skill, through learning, in this case, to play music. So for literature, there's also very interesting stuff. For example, this one's kind of the same, about plasticity. They put professional writers inside a scanner and people that have never written professionally, and they give them a series of tasks, and they found also different activity and different connection in the experienced writers, which shows that creating art, doing art, becoming an artist is actually wiring your brain differently. And also there's some very interesting stuff on poetics and how, even if you don't understand poetics, if you hear, for example, the sound of it, you will have a certain reaction to it, even if you hear it, for example, in another language. So it's like if there was kind of a biological preparation for poetry or for literature, which obviously may not be the case, but it seems like our brains are very receptive to art. Also, one of my favorites is, because I dance, is the neuroscience of dance, and there's a lot of things that are being done on that. And through dance you can explain some concepts such as, for example, proprioception, which is another sense, so we usually hear about the 5 senses, right? But proprioception is another sense through which sensors that we have in our muscles inform our brain of where our body parts are. So you can close your eyes and think of how your fingers in your hand are positioned. And that's without seeing them. And that's because we have proprioceptors, so sensors in our muscles that tells us where our body is. And this is something that's very important, obviously, to dancers, and that every people that do physical activity or yoga learn to interpret better the information from our proprioceptors. Because sometimes we're so paying attention to other stuff that's going on inside and outside that we, sometimes I'm sitting with, for example, with my foot like this, I don't realize until 15 minutes after when it starts hurting, right? So this shows how people that dance, for example, have way more conscience about their body positions. Also about mirror neurons. You've probably heard about mirror neurons. That are the neurons that are activated when you observe an action in somebody else. And they are also related to empathy, because we interpret other people's facial expressions, and that way we understand how they are feeling. So there's a lot of being done now on dance and mirror neurons, and with something called the action observation network. So basically, if you put professional dancers and you show them videos of dance, they have their motor areas activated, as if themselves they were practicing only by seeing. So they have a strong connection between seeing the movement and embodying it. And this also is very interesting. Last one, and then we'll go through the conclusions. This is about cinema. So cinema is interesting for neuroscience in 2 ways. One of them, it's because it can be used as a tool for neuroscience research. So one of the critiques of neuroscience that we do in the lab is that what we show to the participants, for example, in my PhD I was studying visual perception and how we categorize things in the world. So I would bring subjects into the lab and show them very basic stimuli and make them click on buttons whenever they saw it appearing and get feedback, right? So people are, and then we draw conclusions from that. And of course it's very valid, and you need to simplify the phenomena to be able to study them. But some neuroscience want to move to more real life neuroscience, saying, well, life is not like that. You don't get stimuli isolated, like only a visual stimulus of particular characteristics, or only auditory. So people that are interested in performing some more real life neuroscience are using cinema as a first attempt to approach phenomena in a more complex way. Because when you're watching a movie, you're embedded in the experience. You have the visual part, you have the auditory part. If it's a good movie, you have the emotional part engaged. And so while recording brain activity where people watch movies, you can extract some information and do it in a way that resembles more your everyday activity than getting inside a scanner and seeing some very particular stuff that you don't actually see in your real life. So this is a study that has been replicated since and has been done in other ways, in which they put 2 or more subjects seeing the same movie, and they record the activity of their brains. They've also done it doing something called eye tracking. That's basically like a technology that allows to track your eye movements, even those that are imperceptible for your own. You don't realize that you're moving your eyes, but you are doing small movements to scan everything. So basically, what they saw was that while seeing the same movie, they got a huge rate of synchronization of even both brain activity and eye tracking. So people would look at the same kind of things, and they would get synchronized way with different part of the brain because they were looking at the same movie. So that was the inter-subject correlations mean how much the activity was similar in between the subjects, and then they found that it was very high. So it's kind of also the power of cinema, right? It can put us in the same mood, even though we have so different internal words and different interests, and we're thinking about different stuff. We sit down and we see the movie and we synchronize on how we get into the same mood with the people watching movies. Okay, and then the other way around, also another important thing of opening this dialogue between art and science is that neuroscience can also inspire art. So this is a quote from Eric Kandel's The Age of Insight book. That's also a book that looks for the intertwining of science and art in history. He speaks about modernism in Vienna, because this period in Vienna was particularly interesting because there was a big dialogue between the sciences and the arts. So the Vienna School of Medicine and the artists, so for example, Klimt and Kokoschka were really inspired by anatomy and by physiology in their drawings and their paintings, because they were in touch with artists, with scientists, and they were engaging in dialogue. So he speaks about that. And so he says that today, in the same way that Renaissance artists used the relations of anatomy to represent the human body in a more accurate and interesting way, contemporary artists today will be able to create new forms of art and representation thanks to the revelation of brain function. So he's saying also, if artists are able to get close to the functioning of the brain, this will inspire them to create art in different ways. We already know that in a way, so when we spoke about vision of art, there's a quote I like a lot, and it says that each aspect of our vision is illustrated with examples of painters who have mastered the means of fooling it. So artists know more about the brain than they think. I mean, they have interiorized many, many things, and through their work, they engage different parts of our brain functioning. So if they learn even more, they can go further in the exploration of how to stimulate this or that function of the human brain and create more engaging and interesting art. So in that framework, Convergence Perceptions of Neuroscience engages people in a horizontal dialogue. So it not only organizes these Art-Sci talks, but they also give a course here in Concordia that has neuroscience students and art students working together for a year. So what this does is that this neuroscience student shares his project, or her project, their project, with the artist, and they work together to build a work of art at the end of the year. So this engages a horizontal dialogue. It's not the scientist explaining to the artist. It's both exchanging. And in the end, there's very interesting pieces that come out of this interaction. So speaking of that, we invite you to the exhibition that's actually on right now. That's the result of the work of 1 year of the art and science students. It's now on the Visual Voice Gallery on St. Catherine. And then there will be, some of the artworks are being displayed now there. And on April, the vernissage or opening was yesterday, but there's going to be a second one here in Concordia showing other pieces that are more like installations and performances and stuff that's not easy to show in a gallery. So right now it's more static stuff, but you can go see it and seek out like real examples of how neuroscience can inspire art. And then the other one's going to happen in Concordia likewise. So with that, I want to thank you, to invite you to follow my project in my social media and the YouTube channel. I know that it's in Spanish, so for those that do not speak Spanish, I'm gonna add English subtitles soon. It's not complicated, it's just that I need to sit down and translate it and put it, or pay somebody to do it. But I promise soon it's gonna be there. And just close to invite everybody to explore, to communicate, and to be transdisciplinary. Like communicating your passion and communicating your work can inspire others in other spheres to broaden their knowledge, and can also spark thoughts in the heads of people that never thought that would be possible. So because this is very small, these are the books. These are books of because there's this nice predetermined design that PowerPoint offers to people that are impaired in visual stuff like me. So thank God PowerPoint has this nice design stuff that they suggest, but sometimes they do this and they leave that small book. So these are examples of books that can, if you're interested in art and science or art and neuroscience, there's that one, This Is Your Brain New Music by Daniel Editing, who's from here, very famous. Eric Kandel, Reductionism in Art and Brain Science, and the one at the Age of Insight that I already spoke about. Oliver Sacks, who is always a classic when it comes to broadcasting and neuroscience and neurology. So Musicophilia, and then the Biology of Seeing, Vision and Art, Inner Vision, the Aesthetic Brain, and more. If you follow the project, we constantly share stuff about different books and articles and references for people that are interested in these exchanges. And after that, I just wanted to thank the people that work with me in Synapsis. That's Rodrigo Pérez-Gay, he does the animation. That's Ana Laura, she's the communication, communications, I would say communications director, but also she helps to build the content for social media and for the videos in a way that's more understandable to everybody. And that's the producer, Ivan, that organizes the setup, the recordings, and puts kind of everything together. So thank you to them, and thank you for being here. Woo!
So let me put like, and we would like if you guys have questions for Fernanda. So,
can you make me participate to all the experiments that you've talked about? I want to see the lab. I want to be plugged with anything on my brain and.
Oh well, there's in the lab I work for my PhD. They're constantly recruiting participants, and also I guess, well, there's a newsletter for the Center for Research in Brain, Language, and Music, and they're continuously looking for participants for their studies in either music or language or stuff. So you can get your EEG cap with 64 electrodes, and they can record your brain activity, or you can go to fMRI experiments. If you send me your email, and then I know about studies, I'll send it to you.
Awesome.
How is the public perception to your project so far?
So I guess I'm satisfied with it so far. I mean, the first video got like 1,000 views in the first week, which I thought was good. It's obviously not. So there's a couple issues, and I'm glad you brought this up because there's a couple limitations. So one of them is that I'm doing longer videos than what we usually watch in social media, and I knew this was going to be a problem. But at the same time, I wanted to go a little bit more in depth because this is like kind of it's a project that's been like paid for by the Ministry of Culture. It has to have some seriousness to it, right? It's not me blogging from my bedroom and saying whatever. So these are 15-minute videos. So this is too long for social media. And the producer told me, and the guy that does animation told me, we're trying to do shorter videos as well, like so a shorter version of the 15-minute video, a 5-minute video, but that seems redundant. If we already shared the 15-minute video and the small fragments I showed of 1 minute, then putting again the content of 5 minutes is like, oh, like again. So we're exploring that option. One of the options would be like put the complete version on YouTube, and then on social media putting only the 5-minute version. So because the 15-minute version also includes 3 minutes of the experts interview. So for example, in the first one was this neuropsychiatrist speaking about creativity and mental illness. 3 minutes of that. So some introduction, the final part, the conclusion, and some stuff in between, right? So I think that's one of the limitations of sharing in social media, but at the same time, if people have time and they want to go and see it, they can go to YouTube. That's one of it. The other one is that I don't think I still reached the level, like a level that's simple enough for everybody. Like the thing is, reaching everybody is like a big thing to say, right? So you're always going to have people that are already interested either on the brain or on art or something of the sort. But at the same time, for people that don't have biology or neuroscience basis, I've got some comments that I give too many concepts. So I'm speaking about the default mode network, and you saw me today, I speak fast, and I'm trying to like speak slower in the videos, but in terms of content, I'm trying to put too much in, and sometimes I think they can lose a little bit the people. So there's people that are very interested and they want to follow, and I think it's been well received so far. I'm hoping that with the following videos it'll grow. Like the Facebook page has like 2,000 followers date. The video has 1,300 and like slowly growing. The first week was the boom because that was when we released it. And we also have on Twitter also about 2,000 followers. So it's good. I see that people share the content. I see that people retweet the content. But in terms of the videos itself, it's been a struggle. It's been a challenge to find something that's interesting enough for people that know, but simple enough for people that don't know to understand. So if I make it too simple, then some people will be like bored. But if I keep the level, sometimes people are not able to follow. So those are things that I'm continuously working to change. But I'm happy with the reception it has gotten so far, and I hope that it keeps growing.
So, what is your public?
That's the thing, the target public?
Yeah, because right now you want to reach scientists and artists at the same time, and if you remove the content of neuroscience, you're afraid that the neuroscientists will get bored. But if you leave it, then people that don't have base in neuroscience will get loose. So maybe the problem is which target public you want to reach.
Yeah, that's the question I often get, like what's the target? And like my idea was like, I just get it out there and the mythical creature of the general public will receive it, right? But it's true that it's too broad. So there's different people from different spheres. So right now I would say, like, whoever's interested in, like, my idea is to broadcast the neuroscience behind, right? So I don't want to cut down the content on neuroscience, maybe the level, maybe like bring it down, like in terms of don't explain 10 concepts in 5 minutes, you know, because people like need to digest the first one to be able to keep on. At the same time, I mean, they can rewatch it. I mean, I would say that the audience, the target audience is like either, yeah, artists and neuroscientists and all other kinds of scientists that are interested in the intersection between neuroscience and the arts. But I guess I'll have to rethink that, because I just like thought I would just send it in the open and see who but for what I've seen, it's mostly people that are in psychology fields or artists that are more interested in that.
Hi, Fernanda. I first would like to congratulate you. It's very interesting what you're doing. And about the art and science, what do you think about the Harvard School program about Intelligence Zero, where they separate intelligence in different areas like cultural, spatial, linguistic, visual, humanistics, several different types of intelligence that the brain is working, that not everybody has the same skills. So in that case, the brain has so many abilities to interact with the world. So you are focused in arts. That's one of the intelligence that this school is promoting, is like study. But there is interaction with other part of the brain that not only arts. What do you think about this science that you are doing, not only with arts, but with the other part of the brains and other abilities that humans have, not only one intelligence, not only the logical, but also the artistic that you are telling, the humanistic that's quite different from the artistic, the spatial that has to be with the architects, the social that has to be with the leaders that understand humanity in another way. Well, that's very interesting, but how do you connect this kind of knowledge of neuroscience with the other part of the brains?
Yeah, so there's a lot of aspects to that question. If I understand correctly, like what I try to share also in the videos, and that's also some of the limitations, because for some people it would be easiest if I just came and say, look, this is what happens in your brain when you do this, and that's the answer. I often try to say, and the whole point of these videos is, we cannot, like, scientists are not going to explain creativity to an artist. The person that experiences creativity and creates a work of art, whatever happens inside them, we're not going to come here and explain to them, right? We can see what's happening on your brain, we can try to understand the biology behind it, but these phenomena are like multidimensional. So there's the social part to it, there's the cultural part to it, and there's the subjective experience that you get when you either see art or when you create art. And when it comes to different intelligences, I guess, or different skills, I guess that it's all like, I don't see it as separate. I wouldn't say something, it's catchy, but I wouldn't say there's something as an artistic brain. So there's the brain of this particular artist. And artists are, I guess, they're diverse as humanity. I mean, even inside the same field. I mean, this, for sure, musicians will share a lot of skills, but then there's a lot of other aspects of the brains and their personality that are intertwined with their skills. So this is sometimes what I try. Convergent thinking and divergent thinking are different, right? So when you're looking for a particular answer and you're using your executive central network and you're sitting and looking for the answer, you need that. You need that to be for efficacy, you need to be efficient, so you look for a simple answer. But the divergent thinking is more like do free associations, give yourself the time to let your brain rest so that new ideas can come. So from what I've read and from what I know, for me that would be the central message. Like sometimes because we want to do something and we sit in front of a piece of paper and we say, I'm writing the novel now. No, you're not. Like you do what you can do in that moment and then give yourself times of leisure so that your brain can keep working without you forcing it to it. And I guess that's something that can help creativity emerge.
I think you have a question. You were like, okay.
Okay.
So, any other question?
Any question?
You have another question? Go ahead.
Okay, so for example, if I focus a bit more, let's say I want to do a brainstorm. Can there be a way to create some kind of toolbox to stimulate the people who are going to be around the table and to make them reach creative or original ideas?
Yes, there are some techniques, and once again, as I was saying before, most of these techniques come more from the artist side. So we can come as neuroscientists and say, oh, this is what happens in the brain with creativity, but when it comes to artistic creativity, it's people that have been in these domains that can share their personal experience and build things around it. There are, however, also like some tools and some tests and tasks that neuroscientists do when subjects are in the scanner that can sometimes give you an idea, like the divergent thinking tasks, that can give you an idea of how you can apply that in a workshop or in a roundtable to try to engage people with more creative thinking. But yeah, there's stuff being written on art education and that it's described and people that have gone into that.
We can talk at some point with Bettina have actually toolkits that you can use to do boosting of creation when you need to do the divergent thinking. There's many techniques that can be used.
Yeah, see, most of the things it's like trying to engage divergent thinking. But once again, artists are the ones that have explored that more. Because we scientists are very trained to be like very...
I'm not a scientist.
No, I mean,
Okay.
we scientists, or I don't know who else is a scientist in the room, but yeah, but there's stuff I think he can share with you. In the workshop they gave in May, they used some of those techniques, the different exercises, to show people that were in the sciences how they could boost their creativity in other ways and help improve their work, their everyday work. Yeah.
So, any other question?
Sure.
Okay, go ahead. The last one.
Have you had the chance so far to explain neuroscience to an artist to help creating one particular piece of art?
Me? Like,
Yes.
I don't. I honestly don't have had like an experience like that. I wish I would have been still in the PhD when the Convergence course was around, because that's what they do. I mean, these artists, they like the piece is done collaboratively by the artist and the scientist, but they have to explain the science in a way that the artist creates something. But this is like one of the aims of doing this project is to create bridges between artists, especially from the Spanish-speaking community, right? Because it's all in Spanish, but to bring people together, to bring specialists in the neuroscience of art and artists, so that they can exchange. So you sit like a buto dancer in the table and a neuroscience of dance, and you see what they have to. And I'm pretty sure that interesting things will come on both sides. So good ideas for the researcher, and also the artist will be inspired by that. So I'm hoping that this project helps create those